Let me illustrate how to obtain the probability of getting a high or low teaching evaluation score from our dataset. First, an important concept is the standardization of a variable such that it returns a dataset with a mean of 0 and a standard deviation of 1. I use the formula in equation shown here, where the standardization is taking a variable x and subtracting from it the average value mu. Then dividing it by the standard deviation so that if the teaching evaluation score of an instructor on a scale of 1 to 5 is 4.5, we subtract the average teaching evaluation of 3.998 from it and divide it by the standard deviation, which is 0.554, resulting in a z-score of 0.906. If we were to just display the data as a histogram, you would see that it has a mean around 0, and the spread is shown on a scale where the x-axis varies from -3 to 2. In a case where you do not have access to a computer with statistical software, you can still compute probabilities from a probability table using a simple and standard normal table found in statistics textbooks or downloaded online. A copy of such a table is on the right. Notice that the normal distribution graph to the left is grayed out in some parts. That grayed out area represents the probability of getting some value z, in this case z. This value of z, or less than, we will need to first standardize the variable to determine the probability of a teaching evaluation score higher than 4.5 or less than 4.5. So let's say we have a dataset where the average teaching evaluation is 3.998 and the standard deviation is 0.554, and we are interested in determining the probability of getting a teaching evaluation score of 4.5 or less. So, from the table that I showed in the last slide, we can determine this. If we were to standardize the data, it becomes 0.906 because the accuracy of this table is only good for 2 decimal places. So 0.906 effectively becomes 0.91. So we get a 0.8186 value here, hence the probability of obtaining a teaching evaluation score of 4.5 or less is 0.8186. If you were to look at this graphic, you will see that I have plotted the area under the curve by shading it gray. That's the area that depicts the probability of an instructor receiving a teaching evaluation of less than or equal to 4.5, and that probability is 0.8176 or 81.76%. Now, what will be the probability of receiving a teaching evaluation score of greater than 4.5? In fact, you can see from the next graphic that the probability is the reverse of one that we saw earlier, and hence the probability of obtaining a teaching evaluation score of greater than 4.5 is 18.24%, which is the area shaded in gray. The reason for this is because the area under the normal distribution curve is equal to 1. So 1 minus 0.8176 will give you the area for evaluation scores greater than 4.5. Let me illustrate the example of getting a teaching evaluation score of greater than 4.5. In Python, we will use the norm.cdf function in the SciPy stats package. After finding the mean and standard deviation, we plug it into the function with the x value of 4.5, and we will get the area to the left, which is the less than 4.5 area, because we want the area. To the right of 4.5, that is, the probability of greater than 4.5, we will remove the value from 1 as indicated here.